We often use the phrase, "it's not rocket science," to describe something difficult. But strictly speaking, building a rocket is highly predictable. If you calculate the thrust, mass, and orbital mechanics correctly, the physics obey your math every single time. Now, try applying that same mathematical certainty to managing a team of people, shifting a company's culture, or building a brand new piece of software. The equations fall apart. Human systems do not behave like machines. This exposes a major flaw in how we usually solve problems. Most traditional management tools are categorization models. We build a tidy grid in advance and then try to shove messy, real-world data into those rigid boxes, whether the data actually fits or not. To handle unpredictable challenges, we need a sense-making framework. This is where the Cynefin framework comes in. Instead of forcing data into a pre-existing grid, Cynefin asks us to let the real-world data cluster organically first. We let the reality of the situation dictate the shape of our map. If you skip this step, you land in the center of the Cynefin map, a state called disorder. This is the dangerous position of having no idea what kind of system you're actually operating in. When people panic in disorder, they default to their biases. A bureaucrat will demand more paperwork, the right tools for that specific reality before you make a single move. The framework divides the world into two main halves. Let's look at the ordered half first. Here, cause and effect are tightly linked. At the bottom right is the clear domain. In this environment, every action has a predictable, universally understood result. This busy London intersection shows the clear domain in action. Every driver knows to stay on the left side of the road. It is a rigid, universally accepted rule that keeps the system flowing safely. When you are in the clear domain, your decision model is straightforward. You sense the incoming information, categorize it, and respond. Because the rules are fixed, this is the only place where you can safely apply a rigid best practice. But there is a hidden danger here. If leaders over-constrain a system with too many rigid rules, they enter a zone of complacency. The boundary below this domain is a sharp, jagged cliff. One wrong step and the entire system falls directly into chaos. Moving up to the top right, we find the complicated domain. Here, cause and effect still exist, but the right answers are not immediately obvious. The connections are fuzzy and require deep investigation. This brings us back to the launch pad. Building a rocket to reach the moon is a complicated problem. It has thousands of moving parts, but with enough time, highly trained experts can calculate the exact steps required to succeed. In the complicated domain, the approach shifts. You must sense the data, analyze it thoroughly, and then respond. And because different experts might have different, equally valid ways to solve the problem, you rely on good practice rather than one single forced method. If you force a group of brilliant engineers or doctors to follow one rigid checklist without allowing for their expertise, you ignore the nuance of their work. You end up frustrating your team and completely destroying their effectiveness. Now we cross over to the unordered half of the framework. Welcome to the complex domain. In this unpredictable space, doing the exact same thing twice will give you different results every time. If you have ever tried to raise a toddler or build a modern software application, you know exactly what this feels like. The variables are constantly shifting, and the system reacts to every move you make. Because you cannot predict the outcome in advance, long-term planning fails here. Instead, the strategy is to probe, sense, and respond. You run small, safe-to-fail experiments to test the waters, sense how the system ripples in response, and then adapt your next step. To guide a team through this complexity, you cannot use rigid rules. You have to use enabling constraints. These are simple rules of thumb that allow everyone to move in sync while still giving them the freedom to adapt on the fly. Napoleon used this to modernize warfare. Instead of sending slow messengers from a distant hill to dictate every troop movement, he gave his commanders one simple principle: march to the sound of the guns. You can see this same approach in the modern United States Marines. When operating in unpredictable combat environments, they rely on three simple principles: capture the high ground, stay in touch, and keep moving. Finally, we reach the bottom left, the chaotic domain. This is a sudden crisis state with zero constraints and zero patterns. Think of a trauma surgeon receiving an accident victim or a massive building fire. In a true crisis, there is no time to run experiments or analyze data. You must act, sense, and respond. You take immediate, decisive action just to stabilize the situation and stop the bleeding. In the unordered world, strict plans will snap. Survival requires the flexibility to run small experiments or the courage to take immediate action based on a few simple rules of thumb. Every year, organizations waste huge amounts of time and effort on software that doesn't work and projects that stall out. When you add up that lost effort across every industry, the cost is staggering, reaching into the trillions of dollars. This massive loss happens when leaders take inherently complex activities, like writing software, designing a new product, or changing a culture, and manage them as if they belong in the predictable, clear domain. They attempt to control unpredictable creative work with fixed year-long schedules and rigid processes. They apply assembly line best practices to work that actually requires safe-to-fail experimentation. The Cynefin framework will not automatically hand you the correct answer to your problem, but it does something far more valuable. It stops you from applying the wrong problem-solving methodology in the first place. So the next time your team faces a massive challenge, don't start by asking, how do we solve this? First, check the compass. Ask yourselves, what kind of reality are we dealing with?